For the last, 40 years, every big leap in video games has really been about graphics, right? Better textures, higher frame rates, more and more polygons. But what if the next revolution has nothing to do with what you see and everything to do with a kind of computer that just plays by a different set of rules? By the time we're done here, you're going to see how quantum computers are on the verge of creating games that are literally impossible to run on any machine we have today.
No, seriously, think about that. Imagine a game world so complex, so alive, that no classical computer could handle it. And I'm not talking about your high-end gaming rig. I mean, not even a government supercomputer. This isn't about needing a better graphics card. We're talking about games that are built on such a fundamentally different kind of logic, they need a whole new kind of machine just to exist. And look, this isn't some wild sci-fi dream. The researchers behind this are projecting that the first generation of reliable, fault-tolerant quantum computers will be in the hands of developers within the next 5 to 10 years. So the hardware that's going to power these impossible-sounding games, it's already on the way. So where do you even start with this incredible new power? Well, the most obvious and exciting area is something that's been at the very heart of gaming for decades: procedural content generation. You've probably seen it called PCG. PCG is basically the secret sauce behind the endless replayability of a game like Rogue, where every single time you play, it's a brand new dungeon. It's how, way back in the 90s, developers made the unbelievably huge world of Daggerfall, a world that was actually too big to fit on the storage they had at the time. It's all about using code to build a game's world on the fly instead of by hand. The source material really nails it with this quote, calling PCG the artistic application of mathematics. And just like any art form, it's always been limited by its tools. For PCG, the biggest tool, and honestly the biggest bottleneck, has always been sheer computational power. And that is where quantum computing completely changes the conversation. It's not just offering more power, it's offering a totally different kind of power. This is what we call the quantum advantage. So, what does that actually mean? Well, here's a pretty simple way to think about it. Imagine a regular classical computer trying to solve a maze. It has to try one path, hit a dead end, go all the way back, and then try the next path, one by one. But a quantum computer? Thanks to this mind-bending property called superposition, it can, in a sense, explore every single path in that maze at the exact same time. Now, exploring all those paths at once leads to an absolutely staggering speed-up. For a search problem with n different possibilities, a classical computer is going to take, on average, n tries. But a quantum search, like Grover's algorithm, can nail the solution in roughly the square root of n steps. It's called a quadratic advantage, and as that n number gets bigger and bigger, the difference in speed becomes just enormous. Okay, so that's the theory. But how does this abstract idea translate into real tools that a game developer can actually pick up and use? This is where it gets really practical. This table shows the upgrade perfectly. Let's take a common task in PCG, something called exact constraint satisfaction. That's just a fancy way of saying, make sure the level you just generated is actually solvable and follows all the game's rules. Classically, you might use a backtracking algorithm, which can be super slow. The quantum version, quantum backtracking, gets that massive quadratic speedup, making it way more efficient. It's truly like swapping out a handsaw for a power saw. But this is about more than just raw speed. It's about quality. It lets developers finally beat something called the curse of dimensionality and solve what some people call the 1,000 bowls of oatmeal problem. You know that feeling, right? You're in a huge procedurally generated world, but every town, every forest, every dungeon just feels kind of the same. Quantum tools let developers search a much bigger creative space to find the truly unique, the surprising, the interesting variations that make a world actually feel alive. This all sounds amazing in theory, but what would a quantum-powered game actually feel like to play? Well, the paper we're looking at cooked up a great thought experiment, a hypothetical game that would be totally impossible to make without a quantum computer. So let's talk about a game called Knotty Jones. The idea is a little weird, but it's brilliant. You play as a simple knot, right? And your goal is to battle against other, more complex knots. To win, you have to perform a series of moves to change your knot until it shares a very specific, hidden mathematical property with your opponent's knot. So here's how a turn plays out. First, you, the player, make some moves, twisting and changing your knot's shape. Then, and this is the part that's impossible for normal computers, a quantum computer instantly calculates a unique signature for your knot. It's called the Jones polynomial. Just think of it like a super complex, one-of-a-kind fingerprint. If your Knot's fingerprint matches your opponent's, boom, you win the round. So why on earth do you need a quantum computer for this? Because calculating that fingerprint, that Jones polynomial, for a really complex knot is what's known as a hash-p hard problem. That's a technical way of saying it is so monstrously difficult that it brings even the world's most powerful supercomputers to their knees. You can see it on this chart. A classical supercomputer might take 5 minutes for one knot. The quantum computer could do it in 1. But here's the kicker. As the knots get just a little bit more complex, the classical time explodes to hours, then years, while the quantum computer's time barely even budgets.
Let's be super clear about this. This isn't just about making a game run a little bit faster. This is a quantum native game. The core mechanic, the very thing you do to play, depends on a calculation that is fundamentally impossible for any classical computer to do at a reasonable speed. It unlocks a completely new type of puzzle, a whole new way to play that just could not exist before now. And Knotty Jones is just one wild idea, right? It's proof of concept. It shows that once developers really get their hands on this completely new toolkit, the very rules of what a game can be will start to change. So I'll leave you with this question. If you could use this kind of power, what impossible game would you create? I'd love to hear your craziest ideas down in the comments. We are right on the edge of a new era, and the next generation of games, well, it might be more surprising than any of us can even begin to imagine.